Number 1. Which of the following represents the equation of an ellipse? Well, let's go through the basics. The first thing that is easy to identify is the parabola. The parabola will have one variable that is squared and the other is not. Either x is squared and y is not, or y is squared and x is not. Which one is the parabola? Notice that answer choice D has an x squared but not a y squared. So that is the equation of a parabola. The next one that's easy to identify is the hyperbola. In the hyperbola, you're going to have an x squared and a y squared, but one of them is positive and the other is negative. So if you look at answer choice C, x squared is positive, y is negative. Y squared is negative. So that is a hyperbola. Now, for a circle and ellipse, they both have an x squared and they both contain a y squared, both of which are positive. But to distinguish a circle from an ellipse, you need to look at the coefficients. In an ellipse, the coefficients are different. In a circle, the coefficients will be the same. So A is a circle because we have a 1x squared and a 1y squared. B is an ellipse because we have a 4x squared and a 1y squared. The coefficients are different. So B is the answer. Number 2. Which of the following represents the equation of a circle with radius 5 and center 4, negative 3? So first, let's begin by writing the standard equation of a circle. X minus h squared plus y minus k squared, which is equal to r squared. So we have the center, which is h, k. So h is equal to 4, and k is negative 3. So y minus negative 3 is the same as y plus 3. R is 5. So right now we have the equation in standard form, but we need to expand x minus 4 squared and y plus 3 squared to get it into the form that we see in the answers. So let's FOIL x minus 4 times x minus 4. And let's do the same for y plus 3 with itself. 5 squared is 25. X times x, that's going to be x squared. And then x times negative 4, that's negative 4x. And then negative 4 times x, that's also negative 4x. Negative 4 times negative 4 is 16. Next, let's multiply y times y. So that's going to be positive y squared. And then y times 3, which is 3y. And then 3 times y, that's also 3y. And finally 3 times 3, which is 9. So let's combine like terms. We can add negative 4x and negative 4x. That's going to be negative 8x. And then 16 plus 9, that's 25. And then we have y squared plus 3y plus 3y, that's 6y. And all of this is equal to 25. So now we can subtract both sides by 25, which will get rid of this term. So what we have left over is x squared minus 8x plus y squared plus 6y is equal to 0. And so that is the answer, which corresponds to answer choice A. Number 3. Which of the following points represent one of the two foci found in the hyperbola represented by the equation shown below? So is it going to be A, B, C, D, or E? Well, let's figure it out. So first we need to find the vertex, which we could see it's positive 1, negative 2. Don't forget to change the sign. Next, we can see that a squared is 9, which means a is equal to 3. B squared is 16, which means b is the square root of 16, so b is 4. And therefore, we can find c. Using the equation c squared is equal to a squared plus b squared. A squared is 9, b squared is 16. 9 plus 16 is 25. So therefore, c is the square root of 25. So c is 5. C is going to help us to get the foci. But first, let's draw a graph. Just a basic rough sketch, nothing too complicated. So the vertex is at 1, -2. So here's the vertex. Notice that we have a positive x squared graph, which means that the hyperbola is going to open to the right and to the left. A is 3, so if we travel 3 units to the right, we will get one of the vertex. And if we travel 3 units to the left, we can get the other vertex. So the graph is going to open like this, and also towards the left. Now the focus is somewhere inside where the graph opens. So A represents the distance between the center and the vertex. That's A. C, talking about this C, not the center C. C represents the distance between the center and the focus. And C is 5. So if we travel 5 units from the center, we just need 2 more points. That will give us the coordinate of the focus, which is, that's going to be 6, -2. And if we travel 5 units this way, we'll get the point -4, -2. So whenever the graph opens to the right or to the left, here's the equation for the foci. It's h plus or minus c comma k. The vertex is h comma k. So h is 1 and k is -2. So it's 1 plus or minus 5, that's the value of c, comma -2. So when you do 1 plus 5, you're going to get 6. And when you do 1 minus 5, you're going to get -4. The -2 part, the y value, will stay the same. So notice that answer choice B matches this answer. And there's nothing that matches the other foci. So therefore, B is the only answer that we have in this problem. Number 4. What is the equation of the ellipse shown below, or rather shown to the right? Feel free to take a minute and try this problem. In order to find the equation, the first thing we need to do is find the center. The midpoint between 1 and 9 is 5. If you add 1 plus 9, which is 10, and then divide by 2, you're going to get 5. So that's the x-coordinate of the center. The midpoint between 2 and 8 is 5. 2 plus 8 is 10 divided by 2, so that's 5. So that's the y-coordinate of the center. So the distance between these 2 points, between 1 and 5, that's 4. The distance between 5 and 8 is 3. The larger of these two values for an ellipse is A. So we can see that A is 4 and B is 3. By the way, this is the major horizontal axis, which has a length of 2A, that's 8. And then the minor vertical axis has a length of 2B, which is 6. Now that we have A and B, and we have the center, we can write the equation. It's going to be x minus h squared. A is associated with the x-axis because it's horizontal. So over a squared plus y minus k squared over b squared, which is equal to 1. So h is 5 and k is 5. A is 4, so a squared is 16. B is 3, so b squared is 9. This is the equation. Now there's one small detail that I'm missing, and that should be squared. So that is the equation. Both of these must be squared for the equation of an ellipse. So that's it for number 4. That's all you got to do. Number 5. What is the equation of the directrix of the parabola shown below? So let's draw a graph so we can see everything. So first we need to find the vertex, which is -1, +3. And let's go ahead and plot the vertex of the parabola. So we need to travel 1 unit to the left and up 3 units. So here it is. Now, for this particular parabola, will it open towards the right, towards the left, up, or down? What would you say? If it's y equals x squared, it's going to open up or down. But if it's x equals y squared, left and right. Here we have an x, here we have a y squared. So it's either to the left or to the right. Now, because it's positive 12 instead of negative 12, it's going to open towards the right. So it's going to open in this direction. Next, let's set 12 equal to 4p. So 12 divided by 4 is 3. So p is 3. If we travel 3 units to the right, we can get the coordinates of the focus, which is going to be 2, 3. Now, if we travel 3 units to the left, we can get the equation of the directrix. So negative 1 minus 3 is negative 4. Therefore, the equation of the directrix is x equals negative 4, which means that E is the right answer. Number 6. What are the equations of the asymptotes in the hyperbola shown below? So what we need to do is convert this equation into its standard form by completing the square. So let's begin by putting the x variables next to each other. And let's put the y variables next to each other as well. And let's move the 39 to the right side. So let's take out a 4 from x squared and 32x. So we're going to get x squared plus 8x. And let's leave a space. Now, let's factor out a negative from the y squared and the positive 6y, which will now be negative 6y. Now let's complete the square. Half of 8 is 4. So we need to write 4 squared. Now we've added 4 squared times 4, which is 64. So let's add 64 to this side. Half of 6 is 3. So we need to write 3 squared. So we've added 9 times negative 1, or negative 9. So let's add negative 9 to the right side. Now let's factor the perfect square trinomials that we now have. X squared plus 8x plus 16. Two numbers that multiply to 16 but add to 8 are 4 and 4. So it's x plus 4 times x plus 4, or we can simply write it as x plus 4 squared. To factor y squared minus 6y plus 3 squared, you can literally see everything you need. It's y minus 3 squared. Now let's add these three numbers. Negative 39 plus 64, that is positive 25. And 25 minus 9 is 16. So we need to turn this number into a 1. Let's divide everything by 16. 4 over 16, or if we divide it backwards, 16 divided by 4, that's 4. So now we have the equation in standard form, and it looks like this. So we can see that the center of the hyperbola is negative 4, positive 3, based on these values. And we have a positive x squared, so the graph is going to open to the left and to the right. So a squared is 4, which means a is 2. B squared is 16, which means b is 4. So let's go ahead and graph it. So the center is at negative 4, positive 3. Now a is 2, and the graph opens to the left and to the right. So let's travel 2 units to the left, and also let's plot the point 2 units to the right. So the graph is going to open this way, and it's going to open this way. But before we graph it like that, let's use b to get the other points, which are really imaginary points. So b is 4, we need to go up 4 units and down 4 units, which will take us to -1 on the y-axis. Let's make a rectangle. So here are the asymptotes, and our goal is to find the equations of the lines represented in green. And then here's the graph. So we need to know if the slope is going to be a over b or b over a. Notice that we went up b units and we traveled to the right a units. Going up is the rise, going to the right is the run. The slope is rise over run, so it's b over a. So therefore, the equation of the asymptotes is going to be y minus k, which is plus or minus b over a instead of a over b, and then x minus h. Y minus k is basically what you see here. So that's y minus 3. K is positive 3. B is 4, and a is 2. H is negative 4, so x minus negative 4 is x plus 4. And we could reduce 4 over 2. So the answer is y minus 3 is equal to plus or minus 2 times x plus 4. These are the equations of the asymptotes. Number 7. Which of the following represents the equation of a parabola with focus 2, 5 and directrix y equal 1? So first, let's draw a graph. So let's plot the focus. So the focus is at 2, 5. And here it is. The equation of the directrix is y equals 1. So it's this line right here. If this is the focus, then the vertex is somewhere in between the focus and the directrix. It's right in the middle. Now, if this is at a y value of 1 and the focus is at a y value of 5, then the midpoint between 1 and 5 is the y value of the vertex. If we average 1 and 5, 1 plus 5 is 6, divided by 2 is 3. And the graph is going to open up towards the focus. The distance between the focus and the vertex is p. So we can see that p is equal to 2. Now, what is the standard equation for a parabola that opens in the upward direction? Here's the formula that goes with it. It's going to be x minus h squared, which is equal to 4p y minus k. And p is positive too because it opens upward. So remember this, y equals x squared is a graph that opens upward. And x equals y squared opens towards the right. So we have an x squared and a y, which correlates to this function. So let's find the coordinates of the vertex. We can see that the y value is 3, and the x value is the same as the x value of the focus. So therefore, the vertex is 2, 3. So h is 2, p is 2, and k is 3. So therefore, we have x minus 2 squared is equal to 8, and then y minus 3. So that is the standard formula of the equation of the parabola. So now, notice that we have a 0 on one side. So we got to modify the equation that we have. Let's FOIL x minus 2. And let's distribute 8. So it's going to be 8y minus 24. X times x is x squared. X times negative 2, that's negative 2x. That's another negative 2x. And then negative 2 times negative 2 is positive 4. Negative 2x minus negative 2x, or rather negative 2x plus negative 2x. That's negative 4x. So now let's move the 8y to the left side, and let's add 24 to both sides. So it's x squared minus 4x minus 8y, and then 4 plus 24, that's 28. And so this is the equation. It's x squared minus 4x minus 8y plus 28. And so C is the right answer. Number 8. Which of the following is one of the two major vertices found in an ellipse with center -3, 4 and major horizontal axis with a length of 8? So let's begin by making a graph. Now the center is going to be in quadrant 2, so we're going to put the majority of the graph in quadrant 2. So the center is -3, 4, which is right there. Now, the major axis, which is associated with A, it has a length of 8. So 2A is equal to 8, which means A is 4. So to get the vertices, we need to travel 4 units to the left and 4 units to the right. So basically, we need to add 4 to the x coordinate of the center. -3 plus 4 is 1. So the vertices is going to be H plus or minus A comma K. So that's -3 plus or minus 4 comma 1. -3 plus 4 will give us the point 1, 1. Well, K is not 1, but K is 4. So we should get the point 1, 4, which is over here. And then -3 minus 4 is -7. So we should get this point, -7 comma 4. So if we graph the ellipse, it should be something like this. We don't know the value of B, but we don't need to know it. We just need to know the vertices. So 1, 4 is not listed, but -7, 4 is. D is the answer. Number 9. What is the equation of the circle given the endpoints of a diameter which are 1, 2, and 7, 10? So go ahead and try this problem. The majority of the graph is going to be in the first quadrant. So let's focus on that section. So this is 10, and this is 7. The first endpoint is at 1, 2. The second one is at 7, 10. If we connect those 2 points with a line, this is going to be the diameter. And so if we draw the circle, it should be something like this. The radius is the distance between one of those endpoints and the center. So the center is probably somewhere around here. To find the x coordinate of the center, average the x values of the endpoints. If you add 1 and 7, that's 8, and if you divide it by 2, you get 4. So 4 is the midpoint of 1 and 7. The midpoint of 2 and 10, which is the average, is 2 plus 10, which is 12, divided by 2. So it's 6. So therefore, we have a center of 4, 6. The radius is the distance between one of those endpoints of the diameter and the center. So let's calculate the distance between this point and the center. What we can do is draw a circle. Not a circle, but a triangle. That is a right triangle. The distance between 1 and 4 is 3. And between 2 and 6, that's 4. This is a 3, 4, 5 triangle. Using the Pythagorean theorem, a squared plus b squared equals c squared. 3 squared plus 4 squared, that's 9 plus 16, which is 25. And the square root of 25 is 5, which is the hypotenuse. So the radius is 5. So now that we have the center and a radius, we can write the equation of the circle. So here's the generic equation. It's x minus h squared plus y minus k squared is equal to r squared. So h is 4, k is 6. So it's x minus 4 squared plus y minus 6 squared, which is equal to 5 squared, and 5 squared is 25. So this is the answer, and that corresponds to answer choice A. Number 10. What is the equation of the hyperbola with vertices negative 8, 5 and negative 2, 5 and foci negative 10, 5 and 0, 5? So first, let's draw a graph. The majority of the graph is going to be in quadrant 2. So let's focus on that section. So the first vertice is at negative 8, 5, which is about here. And we have another one at negative 2, 5. The foci, one of them is at negative 10, 5, and the other one is at 0, 5. So the hyperbola is always going to open towards the focus. So it opens left and right. The center is basically the midpoint between the vertices. So one of the vertices has an x value of negative 8, the other one is negative 2. What is the midpoint between negative 8 and negative 2? If you add those two values and divide by 2, that's negative 10 over 2, which is negative 5. So the distance between the center and the vertex is 3, which means that A is 3. The distance between the center and the focus, that's 5. This is at an x value of 0. This is at an x value of negative 10. C is the difference between negative 10 and negative 5, so C is 5. The last thing that we need to do is find the coordinates of the center. And we could see what it's going to be. So we can see that it has an x value of negative 5, and the y value is the same as the y value of all the vertices and the foci, which all have a y value of 5. So the center is negative 5, 5. All we need to find is b. For a hyperbola, c is larger than a, so c squared is a squared plus b squared. C squared, c is 5, so c squared is 25. A is 3, so a squared is 9. So b squared is 25 minus 9, which is 16, and b is the square root of 16, so b is 4. So we have a, we have b, and we have the center. So now we can go ahead and graph it. I mean, not graph it, but we can write the equation. So because the graph opens to the left and to the right, the x squared portion of the equation is positive. So it's x minus h squared over a squared minus y minus k squared over b squared, which is equal to 1. And as we can see, a is horizontal. It's parallel to the x-axis. So a is under x. Now h is negative 5, k is 5. So it's x minus negative 5, which is x plus 5, and then squared. A is 3, so a squared is 9. K is 5. Now b is 4, so b squared is 16. Therefore, this is the equation of the hyperbola.